power rule here. So we're doing some basic rules for derivatives in this this section, and this would be part 2 of this. And power rule, if you remember, is that when you start with your power, when you do its derivative, the pattern is that we're going to end up with that original power as a coefficient, and then we're going to be one less in the power. So when you do the algebra, that's what happens every single time. That's the pattern. So we're going to look at some other patterns here. So this is called the sum rule. I like calling it the going Dutch rule. Yeah, please don't use that at any of the math department socials because they will laugh at you. They'll look at you funny. But what do I mean by going Dutch is if you ever gone on a date going Dutch, basically everybody pays their own way. So let's think about this as we go through this. Okay, so what we want to do is we want to start off with a formula with an expression like x squared minus 5, x to the 5th, excuse me. And what we want to do is we want to take the derivative. Well, before we had this expression, this whole limit difference quotient thing going on, where we take x plus h and we plug in for each of the x's, would expand it all out, do the algebra, then we'd subtract the original function. And then with that, we would divide out the h, and then we do the limit by plugging in 0 for h. And when we do all that work, all that algebra, we end up with 2x to the 1st minus 5x to the 4th. And then if we do it to x to the 3rd plus x to the 11th, we do all that algebra, all that stuff, we end up with 3x squared plus 11x to the 10th. And then if we do that to something like x to the 23rd minus x to the 100th, oh my gosh, who'd want to do that? That's a lot of algebra. We basically end up with 23x to the 22nd minus 100x to the 99th. So if you're looking at this, hopefully you're realizing that whenever we have a plus or a minus, we have this basically going Dutch idea. Each one we do individually. It's not a combination of the two, it's each piece individually. And so basically that's our sum rule. Everyone pays their way. We do each term of the expression individually. So that's why if we start with f and g, then basically its derivative is f prime plus g prime. So that's called the sum rule. We've got another rule that's called the multiplier rule. Some people call it the coefficient rule. I like to call it the moocher's rule. And we'll find out why in a second. So we're going to repeat the pattern. We're going to start off with a function like 5x to the squared. We're going to do all that algebra, the difference quotient, the limit, all that stuff. And guess what we get? We get 10x. We could get a 5 times 2 for a 10x. If we do that to 25x to the 3rd, do all that algebra, we're going to end up with basically 75x squared. And then if we do the 11x to the 23rd and we do all that algebra, we end up with the 253x to the 22nd. So basically the question here is, what happens to the 5 to the 25 and to the 11 when we do the derivative and it's a coefficient? What happens? Do these things go away? Are they changed in any way? And what we find out is that when we do the derivative, the coefficients come along for the ride. And that's why I call it the moocher's rule, is because when we do its derivative, they come along for the ride. They're getting it for free. So the steps basically here, when we're doing the derivative, you're leaving the coefficient alone. You do that multiplication of the power when you're done. But in terms of our function notation, if you've got a number out in front of a formula, basically when you do its derivative, you still have that number there. It's coming along for the ride. One more situation we have called special cases. It's also called the constant rule. Basically, if you start off with 5, 24, 2 pi, you do all this algebra with something like that, and guess what we get? We get zeros. So basically, if we're doing a number, because 2 pi is a number. I know it's a nice cool looking number, it's got a nice symbol, but it's a number. When we do its derivative, we get 0. And that's our constant rule. Basically, anytime you take the derivative of a single number by itself, you get 0 automatically, because remember, the derivative is about the formula for how things are changing. And if you're a constant number, you have no change. You're always going to be 37, 23, or whatever number it may be. You don't change, so that means its derivative has got to be 0, because 0 is the way for us to say no change. Okay, so basically those are your nice basic derivative rules. So take a moment, do these expressions that I'm giving you here, these functions, go ahead and apply those derivative rules to these things, and then we'll come back and we will talk through these things.